Okay, welcome to the next video in our electricity lessons on the AQA GCSE physics specification. Okay, right, so I'm going to do this one on thermistors and LDRs. Okay, the main curve or graph that you should be aware of, I'm going to put resistance here. Okay, I'm going to put temperature here, that's degrees Celsius. This is measured in ohms. I'm going to do the component, what the resistance, how it should change with respect to temperature for a thermistor. So here is the circuit symbol for a thermistor. Okay, it's like a resistor with like a hockey stick through it. Okay, what is this telling us? Well, as temperature increases, the resistance is dropping. So it's got this unique capability internally that its resistance actually decreases, so it lets more electrons pass through at lower temperatures, at higher temperatures, sorry. Okay? So please remember how thermistors work. The other device, and look, this is how simple it can be to memorize what LDR does. All I'm going to do now, I'm going to change my temperature label. I'm going to change it to light intensity, so measuring the light level. Okay, so light intensity. We use a unit here, watts per meter squared. Don't worry about the units too much, but this is a measure of how much light our LDR. Let me just draw the circuit symbol. So a light-dependent resistor. Okay, there we go. So what is it telling us? Bear in mind, all I did was I changed this x-axis to light intensity. So from temperature to light intensity, it's telling us at high light levels, the resistance decreases. At low light levels, we have a high resistance. Okay. Where can these devices be used? Well, they can be used in external lights. So, you know, automatic lights when, you might walk past the property and the lights may turn on when it gets a certain light level, when it gets dark. That is dependent on these LDRs, okay? Light-dependent resistors, because they can measure the external light level, and depending on how they're connected to the circuit, they can basically cause light to be turned on or off accordingly. Okay. Same thing with a thermistor. A thermistor can be used in your homes to detect the temperature of your homes, and if it gets below a certain temperature, the heating may turn on or turn off, or the air conditioning may turn on or turn off, depending on what the thermistor records. And its resistance will be dependent on that external temperature, and therefore it can turn on a circuit or turn off a circuit to allow heating or cooling to occur in your homes. Okay, so that's thermistors and LDRs. And you need to remember the shape of these curves for your exams.